Howdy folks. What we're going to do in this video is we are going to discuss a kind of a, I don't want to say it's complicated, but it's a difficult to grasp idea in the subject of calculus. And it involves graphs, which is why I've drawn a graph here. Okay? And what a lot of people call it, or a lot of people think of it as, it's the relationship between the graphs of the function, the graph of y, and y prime, its derivative. See, when we draw the graph of a function, which you've probably been doing for a long time, you can write an equation, then maybe in a graphing calculator or on paper you can sketch the graph of a function. But here's the funny thing is, because derivatives are also functions, we can draw their graphs as well. Just to give you a quick example, let's say that y is equal to x squared. That means that y prime, the derivative, is 2x. This is a function, and its graph is a parabola. This also is a function, 2x, and it also has a graph, and it looks like this. Okay, so this is the graph of 2x, and this is the graph of x squared. And here's what I'm telling you, is that these two graphs are related to each other. There are qualities about this graph that tell you what this graph should look like. And there are qualities about this graph that tell you what this graph should look like. And what I'm going to do in this lesson is I'm going to give you basically 5 different principles that if you understand these 5 basic rules or ideas of the relationships between the graph of a function and the graph of its derivative, if you can understand these things, then you should have no problem eventually developing the skill of being able to recognize the graph of a derivative when you have the graph of a function, or given the graph of the derivative, then recognize the graph of the original function. So here's what I want to do to start this, sort of get your brain ready to understand this, is I want to point out that there are basically, there's lots of ways to look at this, but I'm going to say that there are kind of 5 different kinds of shapes, basic shapes. Now, we can make it more detailed than that, but if we look at the graph of any function, I'm going to break up a function into 5 basic shapes, okay? And they're based on 2 qualities, okay? The first quality I'm going to call slope. I'm going to call it the macro slope, okay? And when I say macro slope, there are 3 possibilities when talking about slope from a macro point of view. And the first one is that slope can be positive. So a function can have a positive slope, or it can have a negative slope, or it can have a slope of 0. Those are the 3 possibilities, okay? Positive slope goes like this, negative slope goes like this, and a 0 slope is flat. That has a 0 slope. So this line has a positive slope, this line has a negative slope, and this line has a 0 slope. And so we can understand any graph as either having a positive slope at any one point, and it can be different at different points. For example, this graph here has a positive slope, but over here, this graph has a negative slope. See, and we read graphs from left to right. So from left to right, this graph is traveling upwards. Whenever a graph is traveling upwards, it has a positive slope. Here, the graph is traveling downwards. Wherever a graph travels downwards, the graph has a negative slope. But then there's also the places where the graph is traveling sideways, and that's usually at the bottoms and the tops of these hills and valleys. Here, the graph is not, at that point, it's not traveling up or down, it's basically just flat sideways, and so it has a slope of 0. So we have a positive slope, a 0 slope, and a negative slope. Negative slope, 0 slope, positive slope. So that's the first thing that you have to understand about graphs. Now, this is a macro point of view. Now, I will say that there are other possibilities. There are places on graphs, and we're not going to discuss these right now, but there are places on graphs where a graph has no slope, or where it has what some would call an infinite slope, meaning a vertical slope. But right now, we're not concerning ourselves with that. You can worry about that later. For now, the basic ideas are that any graph has a positive slope, a 0 slope, or a negative slope. So those are our 3 macro slope ideas. So a graph has its macro slope, that's the first quality, and then the second quality is what I would call, so let's call this 1. The second one is what I call steepness. Steepness. How steep is the slope? And so steepness, we can say that it is steeper, or we can say that it is flatter. Steeper or flatter. Those are your 2 possibilities. Okay, so we don't have steeper and flatter for a slope of 0, but we can have steeper or flatter for positive and negative slope. Like right here. At this spot right here, the slope is positive and steep. So steep and positive. But over here the graph, the slope is positive and flatter. Okay, so here it's steeper and here it's flatter. And you can see that it's a little bit different. This is flatter, you know. If positive and steep looks like this, positive and flat looks like this. Positive and steeper, and positive and flatter. We can also have that with negative slope. Here, let's say right here, the slope is negative and steeper. Kind of steeper. Maybe not as steep as this. We could have a slope that goes like this, negative, and that's really steep, right? And that's okay, that's good. But right here, the slope is negative and flatter. Negative and flatter, okay? So these are the 2 qualities, slope and then steepness. And what we're talking about here, so what I want to do is, I'm going to erase this. What I'm basically talking about here, and this is the way that I communicate it, or I've communicated it for a long time to my students, is that when we talk about the relationship between the graphs of y and y prime, here's what I want you to understand, is that the derivative of a function, y prime, is determined by, or you can say it determines, because it goes both directions, is determined by we're talking about the shape of the graph of y. What is the shape of the graph? And the shape of the graph is very important in the subject of calculus. Okay? So that's what we're talking about here. So we have 2 qualities of shape. We have the macro slope, whether the shape of the graph has a positive slope, a negative slope, or a 0 slope. And then the other quality of shape is whether the shape of the graph is steeper or flatter. Okay? And so here's what we're going to have. I'm going to create I'm going to put slope here, and we're going to say positive, here's slope, we're going to say positive, negative, and then 0. And then for steepness, we're going to put flatter or steeper. And now I'm going to create a chart. Okay? Now, zero slope doesn't really count. Okay? We can't have a zero slope flatter or steeper. Okay? So zero slope, it is what it is. Okay? Zero slope just means it's entirely, completely, and utterly flat. That's when it's totally flat. Not flatter, but completely flat. So now we're looking at four basic shapes here. We have positive and flatter. That looks something like this. And then positive and steeper. And that looks more like this. Negative and flatter would look like this. Negative and steeper would look like this. Okay? And so those are our, and let's get rid of zero over here. So this really is what we're concerned with understanding. And so here's what I'm going to do, is I'm going to give you 5 qualities or 5 indicators, 5 concepts, 5 concepts that will help you understand how to recognize the relationship between the graph of y and the graph of y prime. Okay, before I give you these concepts, I need to explain the difference between 2 ideas in math, and a lot of students struggle with these ideas. I need to explain the difference between the word positive and the word increasing. Okay? And I need to explain the difference between the word negative and the word decreasing. Okay? And so, the reason that I feel like I have to explain the differences among these words is because for as long as I have been teaching calculus, I have noticed that students have a difficult time distinguishing between the word positive and the word increasing. And they have difficulty distinguishing between the word negative and the word decreasing. Okay? And so here's what I'll do, is I'll have a graph. Let's say that I have an arbitrary graph of a function, and let's say that it looks something like this. All right? I like cubic functions, or graphs of cubic functions. They show a lot of qualities that I need to explain. So here's the deal. What I'll do is I'll say to students, hey, at this point, tell me about the slope. And what they'll say is, or I'll say, what is the graph doing at this point? And what they'll do is, they'll say that the graph is, actually, hang on, that's not a good example. Wait a minute. Yeah, I'll say, tell me about the slope at this point. Tell me about the slope. Actually, I just realized it is a good example. I'll say, tell me about the slope at this point. And this is what they'll say to me. Oh, Mr. Ryan, the slope is increasing. And that is incorrect. I mean, it's not that the slope is not increasing. In fact, actually, no, I can tell the slope is not increasing at this point. Okay? What they'll say is that the slope is increasing. And what they mean to say is that the graph is increasing, the function is increasing, not the slope of the function. Or what they mean to say is that the slope is positive. See, when you say the slope is positive, that means increasing. But we don't generally say that the slope is increasing. That is a reference to the second derivative, which we haven't discussed yet. Okay? So, at this point, you can say one of 2 things. You can either say the graph is increasing, or you can say the slope is positive. the graph has a positive slope because the graph is increasing. And this is the relationship between the words positive and increasing. Here's what I want to say. Positive means to have a value greater than 0. That's what positive means, to have a value greater than 0. But the word increasing means to have a positive slope. That's what increasing means, to have a positive slope. Or increasing also means to have values that, are becoming larger. That's also what increasing means. Increasing means that your values are getting larger. And a lot of people don't understand that to go from -4 up to -3 means that your values are increasing. So having negative values, but if those negative values are getting larger, then your values are increasing. Okay, so increasing means to have a positive slope or to have values that are becoming larger, or you could say we could combine the definition of positive with this definition of increasing and say to have slope values that are becoming more greater than 0. Okay? And that's really confusing. So that's why it's important. I think that what you should just understand is, this is what I want you to understand, is that positive means that the values are larger than 0, and increasing means to have a positive slope. So that's the first thing I need you to understand. Similarly, negative, sometimes I'll show a graph and I'll say, well, tell me about the slope at this point. And they'll say the slope is decreasing. And I'll say that is true. At this point, the slope is decreasing. However, that's not what I was asking you. I didn't ask you if the slope was decreasing. I was asking you whether the slope is positive or negative. Saying that the slope is decreasing is not the same thing as saying that the slope is negative. In fact, at this point right here, at that point, the slope is positive, but the slope is also decreasing. See, the slope is positive, but it's approaching 0. And when something is positive but approaching 0, it's decreasing. So the reason they would say that the slope is decreasing is they're really saying that the graph is decreasing, and that means that the slope is negative. And so this is what I'm saying, is that the definition of negative means to have a value greater, or excuse me, not greater, to have a value less than 0. And then decreasing means to have a negative slope. It is very important to understand the distinctions in these sentences, because I'm going to use, or in these statements, I'm going to keep using these words over and over and over again. And if you don't understand the difference between them, you could become very confused. And these words are very important to understand. The relationships among these words are important so that you can understand the relationship between a function and its derivative. Okay? All right, so now that we've done that, now we're going to go on to our 5 concepts. I'm going to give you what I call 3 macro concepts, and then I'm going to give you what I call 2 micro concepts. And you need to kind of memorize and understand these macro and micro concepts. The first macro concept goes like this. And this is the relationship between y and its derivative, y prime. The first macro concept is whenever y has a slope of 0, y prime has a value of 0. Well, what does it mean to have a value of 0? Doesn't a value of 0 mean that you are on the x-axis? If a function equals 0, doesn't it equal 0 wherever it's crossing over the x-axis, right? Because that up here, this is positive 1, positive 2, positive 3. Down here, this is negative 1, negative 2, negative 3. That means on the x-axis, y is equal to 0. So that is a 0, correct? Crossing over the x-axis. So whenever y has a slope of 0, y prime has a value of 0, meaning it hits the x-axis. Okay? And so I'm going to clean up this macro concept. This is the way I'm saying it first, but now basically what I'm just going to say is whenever y has a slope of 0, y prime hits the x-axis. Okay? Let me show you what that would look like. Let's say I have a graph over here. Let's say that this is the graph of the original function. Again, I'll do a cubic function here. Now, this point right here, at this point, the slope of this function is 0. It has a slope of 0. Positive slope, negative slope, slope of 0. That means that at this x value right here, the derivative is going to hit the x-axis. It's either going to cross over the x-axis or it's going to just touch the x-axis. So that's the first macro concept. The second macro concept is whenever y has a positive slope, which means that y is increasing. Whenever y has a positive slope, y prime will be above the x-axis. Above the x-axis. Why? Because the derivative y prime is the slope of the function. We've said this several times. Y prime is the slope of y. The derivative is the slope of the function. So if the slope of y is positive, then the value of y prime will be positive. And what does it mean to have a positive value? A positive value means above the x-axis. For as long as you've been reading graphs, haven't you understood that whenever a graph is above the x-axis, its value is positive? Everything above the x-axis is positive 1, positive 2, positive 3. If it's negative 1, negative 2, negative 3, that's below the x-axis. So, whenever the original function has a positive slope, then the derivative is going to have a positive value, meaning it's above the x-axis. So, you see this all the way along here where this graph has a positive slope? That means that the derivative is positive. It is above the x-axis. It is up here somewhere. It's up here, not below the x-axis. Over here, look. Here, the slope is 0. That means that the derivative must cross over the x-axis. Right here, right? And from here on, the graph has a positive slope. That means that the derivative is positive above the x-axis, right? Above the x-axis. Last macro concept, hopefully you saw this coming. Whenever the function y, whenever the graph of y has a negative slope, the graph y prime will be below the x-axis, will be below the x-axis. And I'm going to do a bunch of examples in a little bit of this. All right, so when y has a negative slope, that means the slope is negative. Y prime, the derivative, represents the slope of the original function. Therefore, y prime is negative. It has a negative value. Having a negative value means you are below the x-axis. And so, here, from here to here, this graph has a negative slope. Therefore, the derivative will be below the x-axis. So the derivative, this derivative that we're trying to figure out, it's positive, then 0, then negative, then 0, then positive. So it's up here, then it hits here, then it's down here, then it hits here, then it's up here. So I think this is kind of what the derivative looks like. It's positive, now it's negative, it hits here, the x-axis, and it hits the x-axis here, and then over here it's positive. So the derivative of this cubic function is what you see, that's a parabola, which makes sense because the derivative of x to the third power, if y is x to the third power, then y prime is 3x squared. If the original function is cubic, then the derivative is quadratic, and that makes sense. Okay? All right, so those are the macro concepts. Let's look at another. What I'm going to do right now is to look at these macro concepts. We're going to break right now, and I'm going to break from this right now, and I'm going to show you some stuff on my computer. Okay, so what we're going to do here is we're going to look at these macro concepts, and we're going to try and understand them in terms of relating graphs. So we have a situation here where we have this quadratic function. It's a parabola, x squared, and we want to know whether this is the correct graph of the derivative, or is this the correct graph for the derivative. So let's look at the first macro concept here. Whenever y, the original function, has a slope of 0, y prime hits the x-axis. Okay, well this graph has a negative slope here, and then a positive slope on the right side, but here at 0, at x equals 0, the slope is 0. It's flat, okay? So the derivative that we're dealing with should hit the x-axis when x is equal to 0. Well, this one, look, it hits the x-axis when x is equal to 0, but this one down here also hits the x-axis when x is equal to 0. So either one of them could be the derivative. But macro concepts 2 and 3 give away the correct derivative because it says whenever y has a positive slope, y prime will be above the x-axis. Well, where does this graph have a positive slope? On the right side. Positive slope on the right side. And therefore, the right side of the derivative should be above the x-axis. This is the x-axis, this is above. This one is above the x-axis on the right. This one down here on the right-hand side is below the x-axis. So this cannot be the derivative. Similarly, macro concept 3, whenever y has a negative slope, the derivative will be below the x-axis. Well, this has a negative slope on the left side. That's a negative slope. It's going from reading it from left to right. The values are getting smaller. They're going down, down, down. Okay? And so this derivative here is above the x-axis on the left-hand side. So this can't be correct. But this one on the left side is below the x-axis. So this one is the correct derivative of this function. Let's try another one. Okay, here we have another situation. We have this function. It's a cubic function, up, down, up. And this is this parabola is possibly the derivative of this, or this parabola is possibly the derivative of this. So let's go to macro concept number 1. Whenever y has a slope of 0, y prime is going to hit the x-axis. So it looks like this graph, it has a slope of 0 right here at the top. Okay, that's a slope of 0. This is a positive slope. This is a negative slope. And between the positive and negative slope is a slope of 0 at the top. So this looks like that's happening at about x equals maybe negative, not quite negative 1. So over here, this one hits the x-axis almost at negative 1, but this one also hits the x-axis at almost negative 1. So it's got to be, so either one could be the derivative. There's another place where this has a slope of 0, right down here, and that's right at about x equals 2. And this one, look, it hits the x-axis just about at x equals 2. This one also hits the x-axis at about x equals 2. So we need to find out which of these two is the derivative. Well, when we go to macro concept 2 and 3, whenever y has a positive slope, the y prime, the derivative, will be above the x-axis. Well, this original function has a positive slope, then a negative slope, and then a positive slope. Therefore, the derivative should be above, then below, then above the x-axis. Now this one down here is below, and then above, and then below. So that's not correct. This derivative is indicating a function that first has a negative slope, then a positive slope, then a negative slope. In fact, if I draw it, it would look something like this. Okay, it would have first a negative slope, then a 0 slope, then a positive slope, then a 0 slope, then a negative slope. That's what this derivative is indicating. And this graph does not look like this. This one indicates we have positive, then negative, then positive. This is indicating a positive slope, then a 0 slope, then a negative slope, then a 0 slope, then a positive slope, which this looks very similar to what we're seeing right here. And so this is the derivative of that. Okay? And so these are the three macro concepts that can help you understand when you're looking at a graph. Is this the derivative of this function? You're going to be looking for where the original graph has a slope of 0, where it has a positive slope, where it has a negative slope, and then that would indicate where the original, or where the derivative, excuse me, that would indicate where the derivative is above the x-axis and below the x-axis. Okay? Okay, so hopefully now you have a better understanding of these three macro concepts. Okay, the idea of when the derivative is 0, when the derivative is positive, and when the derivative is negative. Okay, so hopefully you have an understanding of that. Now what I'm going to do is I'm going to go over two what I call micro concepts. These are what we're going to do is we're going to fine-tune your now existing understanding of the relationship between the derivative and the graph of the derivative. Okay, there's two micro concepts. The first one is this: when y is flatter. When y is flatter, y prime will be closer to the x-axis. Here's what I mean. Wouldn't you agree that when a graph is flatter, its slope is closer to 0? See here, the slope over here is like -5. But over here, the slope is like -1/2. So wouldn't you agree that the number -1/2 is closer to the x-axis than -5? If we looked at a coordinate plane, -1/2 is here and -5 is way down here. -5 is farther away from the x-axis than -1/2 is. And therefore, since the slope of a function, since the slope of a graph is the derivative of the graph, since whatever the value of the slope is the value of the derivative, when the slope is smaller, or not smaller, excuse me, when the slope is closer to 0, when it's flatter, then that means the derivative will take on a value that is closer to the x-axis. Same over here. Look, here's the slope is 0, right? That means it's touching the x-axis. Now here, it's not 0, but it is very flat. Here, the slope is maybe 1/3. And 1/3 is a number that is very close to the x-axis. But over here, the slope is 2. The slope is 2, and 2 is farther away from the x-axis. And therefore, when y is flatter, when the shape of y is flatter, then the derivative y prime is going to take on a value that's closer to 0. Y prime will be closer to the x-axis. And then the other micro concept is when y is steeper, y prime will be farther from the x-axis. Okay? And what that means is this is steeper. When a graph is steeper, then its slope is either much more positive or much more negative. And numbers that are much more positive or much more negative are farther away from the x-axis. -10 is farther away from the x-axis than -1. And -1, a slope of -1 is flatter than a slope of -10. +20 is a slope of +20 is much steeper than a slope of 5. And therefore, the number 5 is closer to the x-axis than the number 20. And so, these micro concepts will help you recognize the difference, or recognize how to understand the relationship between the shape of the original function and the values of the graph of the derivative. Okay? And so what I'm going to do right now is I'm going to show you a few more examples where we combine these 3 macro concepts with these 2 micro concepts. We're going to do that on my computer right now. Okay, so let's look at these micro concepts, 1 and 2, when looking at the graph of a function and its derivative. What I have here is I have 2 different functions, and what I have over here are the 2 possible derivatives. As you can see, these are linear functions, and linear functions have constant slopes, and therefore their derivatives are going to be constant functions. Okay, so one of these, one of these 2 is the derivative of this, and then the other one is the derivative of this. Well, here's what it says. It says microconcepts. It says when the original function y is flatter, y prime, the derivative, will be closer to the x-axis. Then when y is steeper, the derivative y prime will be farther, this should be farther from the x-axis. Let's see if I can fix that. Farther from the x-axis. Okay, that's better. Whoops, sorry about that. And let's go back down here, and there we go. Okay. Slide this over a second. There we go. Okay. All right, so when y is steeper, y prime will be farther from the x-axis. Well, is this one flatter or is it steeper compared to this one? This one right here is steeper, and this one is flatter. Therefore, the derivative of the flatter one should be closer to the x-axis. Well, here's the x-axis in this one, and here's the x-axis in this one. Is this graph closer to the x-axis or farther from the x-axis? Is this graph closer to the x-axis or farther from the x-axis as compared to this one? We can see that this graph is closer to the x-axis and this graph is farther from the x-axis. Therefore, the one that's farther from the x-axis belongs to the function that is steeper. So this derivative belongs to the steeper graph. This one is the flatter graph, and therefore its derivative is the graph that is closer to the x-axis. Okay, so that's this is a simple situation. Let's now try one that's a little more complicated. Okay, here we have another situation. We have two quadratic graphs, and then we have two derivatives, two possible derivatives. In this one, look at this curve here. Does this curve look like it's steeper or flatter compared to this one? This one looks like it's a little flatter, right? And this one's a little bit steeper. Okay. Well, if this one's steeper, then its derivative should be farther away from the x-axis. And if this one's flatter, its derivative should be closer to the x-axis. Well, this is weird because both of our derivatives cross over the x-axis. But that makes sense because remember the macro concepts is that when the slope is 0, both of them have a slope of 0 at x equals 0, right? So both of the derivatives should be crossing over the x-axis. Both of these functions have a negative slope and then a positive slope. Negative slope, then a positive slope. So by the macro concepts, they should both have, the derivatives should have a negative value and then a positive value. So below the x-axis and then above the x-axis. And both of them are. This derivative is below the x-axis on the left. This one is also below the x-axis on the left. This derivative is above the x-axis on the right. This derivative is also above the x-axis on the right. But I want you to notice at x equals 2 here, this derivative is 4 units away from the x-axis, whereas this one at x equals 2 isn't even 1 unit away from the x-axis. So this derivative is much closer to the x-axis than this derivative is. And this original function is steeper and this original function is flatter. Therefore, this original function has a derivative that is closer to the x-axis, which means this derivative. So this derivative goes with this original function, and since this original function is steeper on the left and steeper on the right, its derivative is farther away from the x-axis on the left and the right. So this derivative belongs to this function. Okay? Let's do one more example of these micro concepts. Okay, here's one more set of examples. What we have here is this is a cubic function. This is also a cubic function. They both look very similar, right? Except this one is a little bit flatter on the left, and this one is a little bit steeper on the left. This one is a little bit flatter on the right, and this one is a little bit steeper on the right. Okay? And so, when we look at the derivatives over here, you can see that this one right here, the one that's flatter, its derivative should be closer to the x-axis. And you'll notice here, if we come over here, at x equals 1, this one is about 3 units away from the x-axis. But here at x equals 1, this graph is much closer to the x-axis. And because this graph is much closer to the x-axis, at x equals 1, this one must come from a flatter original graph, which means that this derivative belongs to this function. This derivative that is much farther away from the x-axis must go with a graph that is much steeper, which is this graph right here. Okay. Now notice that both of these graphs at x equals 2 have a slope of 0. They go flat, right? Both of them go flat. And since they both go flat, that means that their derivatives should touch the x-axis. They're totally flat, so then the derivative should be totally close to the x-axis, which means touching the x-axis. And notice here, at x equals 2, this derivative does touch the x-axis. Here, this derivative does touch the x-axis at 2. Notice also that both graphs have a positive slope, then a zero slope, then a positive slope. Positive slope, zero slope, positive slope. And so their derivatives should have a positive value, then zero value, then positive value. That means above the x-axis, touching the x-axis, and above the x-axis again. That's exactly what's happening in these derivatives. They are both above the x-axis, then touching zero, then above the x-axis again. This one is above the x-axis, then touches zero, then it's above the x-axis again. But because this original graph is flatter, its derivative the values of its derivative are closer to the x-axis, whereas the values of this derivative are much farther away from the x-axis. Okay? So that's the concept, the two micro concepts regarding flatness and steepness. And so now hopefully after doing a few of these examples, you can understand, or you can begin to understand, and it takes a while to really get this understanding, the relationship between the graphs of y and y prime. And this knowledge that you're getting right now is going to help you with the next couple lessons that we do. But for now, what I want you to do is make sure that you do the exercises that I give you, and make sure that you do the quizzes, and they're going to be more of this recognizing and matching up the graph of the original function with the graph of the derivative.